A blessed day to each and everyone. Again, welcome back to my channel. So today, we're going to talk to another field, which is statistical research in behavioral science. This is about introduction of statistics. We're going to cover the following part, which includes the preview of statistics, science and observation, data structures, the research methods and its statistics, variables and measurement, summary, and then we're going to have the part 2 for focus on problem solving, demonstrations, and problems. At the end of this lesson, we shall be able to define the terms population, sample parameter, and statistic, and we're going to describe the relationship with each other. Then we're going to define what's descriptive and inferential statistics and how this is being used in a typical research study. After which, we're going to create a fundamental problem that inferential statistics must address. And we're going to talk about the concept of sampling error. Let's talk about definition of statistics, the population, sample, and sampling error. So before we begin our discussion of statistics, we will read the following paragraph by Rong Sui, last 2000. It stated here that life is seen as a cosmic journey, a struggle to overcome unseen and unexpected obstacles, at the end of which the traveler will find illumination and enlightenment. Replicate this quest in your home by moving light switches away from doors and over to the far side of each room. Our goal is to do everything possible to prevent us from stumbling around in the dark by providing lots of help and illumination as we journey through the world of statistics. Let's define statistics. So, statistics is a branch of mathematics. It's a general field of mathematics and it has facts and figures. It's a summarized and evaluated research that results in the behavioral science. When we talk about behavioral science, this is any of various disciplines dealing with the subject of human actions. And statistics is usually informative, time-saving because they condense a large quantities of information into a few simple figures. So, let's take an example for this statistics. Let's remember the acronym OSI. It is used to organize, summarize, and interpret the information so that the researcher can see what happened in the research study and can communicate the results to others. And it also refers organizing, summarizing, interpreting information. So this is the OSI. We just simplified it from the definition up above. So statistics will going to help researcher to answer the question, initiated the research by actually finding out the conclusions which is justifiable based on the results that had been obtained through statistics. So for example, we want to know whether a junior high school student learn better by modular or by online. So we have to gather some information about the students' habits. We have to gather their academic performance as well so that we can get the results. When a researcher finishes the task of gathering information, we typically find themselves with pages and pages of measurements such as preferences, personality, scores, opinions, and so on. So this is an example of statistics. For example, we have here for the dark green, these are the fully vaccinated individuals in the Philippines. For the light one, these are the people that has at least one dose of vaccine. So it means here that statistical procedures will going to help us ensure that the information or observations are presented and interpreted in an accurate and informative way. Thus, the statistical methods that is used by one researcher might be familiar to other researchers, who can actually interpret it accurately, the statistical analysis, with a full understanding of how does the analysis was done and what does the results signify. So that's statistics. Now let's go with number 2, populations and samples. For the population, this is the collection of outcomes, responses, measurements, or counts that are of interest. It can be specific and they vary in size. It can be small to a very large one, which depends on the researcher on how she define population. And also, it does not necessarily need to consist of people. We can have rats, corporations, parts that had been produced in a factory, or anything else that the researcher wants to study. For the sample is the subset of population. It's the representative of its population, and it can be identified in terms of population from which it was selected. It's a set of individuals selected from a population, usually intended to represent a population in a research study. So for example, one study might examine a sample of 10 educational management graduate studies program. And another study might use an example of 5,000 people who's taking educational management graduate program that has high blood pressures. So far, we have talked about a sample being selected from a population. This is actually only half of the full relationship within the sample and its population. Finishes examining the sample, our goal is to generalize the results back to the entire population. So, as I have mentioned, again, sample is a subset of population. So this will be your population and this will be the sample. So, in population, for example, all likely voters in the next election. This is your population. So, for the sample, you're just going to select 1,000 voters selected at a random interview. You have your sample as the all sales receipts for November. You can have your sample as the random receipts selected for audit bill. Let's talk about some examples in identifying data sets. So in a recent survey, 4,501 adults in the Philippines were asked if they think global warming is a problem that requires immediate government action. 939 of adults said yes. We have to identify the population and the sample, and we're going to describe each data set. So, what will be your answer? I'll be giving you 5 seconds to think. Thus, the answer is the population will be the responses of adults in the Philippine population, and your sample will be the responses of adults in the survey. Let's talk about data. Earlier, we defined population and samples in terms of individuals. So for example, we discussed a population of graduate students of educational management and a sample of those who have high blood pressure. Before born, however, that will not also refer to population or sample scores, because what's happening here in research typically involves measuring each individual so that they can obtain a score, every sample or population of individuals, which produces a corresponding sample or population of scores. So when we call data, when we talk about it, it's a collection of measurements of observations. Take note of the collection of measurements of observation. This always refer to a plural term. And when we talk about datum, it's a single measurement of observation, and here it's usually a singular one. So here we have to find, in order for us to get the data and datum, we have to solve it. We have to find the z-score of a sample, and we'll need to find the mean, variance, and standard deviation of sample, which will be discussed later on. So in calculating the z-score, we have to find the difference between the value in the sample and the mean, and then we have to divide it with the standard deviation as we are seeing in the illustration. So here we have talked about the statistics, sample, population. Now let's talk about the descriptive and inferentials. But first and foremost, let's talk about parameters first. When we talk about parameter, this is a value, usually a numerical value that describes a population. And it's derived from the measurements of individuals in the population. It's also the same with statistics. The difference is that in statistic, we are deriving it from the measurement of the individuals in the sample. So in the previous slide, we have defined the data. So when we describe data, it is necessary to distinguish whether that data come from a population or sample. So a characteristics that describe a population, for example, is the average score for the population is called a parameter. This is a parameter. And the characteristics, again, that describe the sample is a statistic. So the average score for a sample is an example of statistic. However, the actual data come from a sample and are used to compute sample statistics. Let's take an example here. In parameter, a number that describes a population or characteristics. So for example, average age of all people in the United States. So this is a parameter. When we talk about statistic, here we are getting the average age of people from a sample of 3 states. So we can see the difference. We are measuring the sample in the statistic, and in the parameter, we are measuring the population. Another example. So let's decide whether the numerical value describe a population, parameter, or a sample statistic. Number 1, a recent survey of sample of NBAs reported that the average salary for an NBA is more than 82,000 pesos. So let's try to guess, or let's try to answer rather, which is the parameter and statistics. So here, this is a sample statistic because we're talking of the average of 82,000 pesos, which is based on the subset of population. Another one, starting salaries for the 667 information technology graduates from Holy Angel University increased in 8.5% from the previous year. So is this a parameter or a sample statistic? This is a parameter because here we are talking about the percent increase of 8.5%, which is based on all 667 graduates' starting salaries. So if we already know about the parameter and statistics, now let's move on with descriptive and inferential statistical methods. It's also called as the branches of statistics. When we talk about descriptive, it involves in organizing, summarizing, and displaying data. If you can see tables, charts, and graphs, then this is descriptive. But when we talk about inferential, this is a sample data wherein we can draw conclusions about a certain population. So let's have an example. If we say a teacher arranges the scores obtained by his students in a graph, take note of the graph. Is this descriptive or inferential? It's descriptive. Next one, a researcher may wish to find out whether exposure to population may reduce lifespan. So it derives conclusion. So this is a inferential. So here we have another example. We have to decide which part of this study represent the descriptive branch of statistics and what conclusions might be drawn from the study using an inferential statistic. There is a large sample of men aged 48 and was studied for 18 years. For unmarried men, approximately 70% were alive at the age of 65. For married men, 90% were alive at the age of 65. Can we show which is the descriptive and which is the inferential? For the descriptive, it has the statement, for unmarried men, approximately 70% were alive at the age of 65, and unmarried men 90% were alive at 65. So we are talking about percentage graphs and tables. And here, a possible inference drawn from the study is that being married is associated with a longer life for men. So this one is the inferential because it draws conclusion. And this is an example of a sampling error. In the concept of sampling error, it's being illustrated in an example below. So here, we are showing a population of 1,000 college students and 2 samples. There are 5 students who were selected from the population. We have to notice that each sample contains different individuals who have different characteristics, of course, because the characteristics of each sample depend on the specific people in the sample statistics that varies from one another. For example, there are 5 students in sample 1 and have an average of 19.8 years, and the student in sample 2 have an average of 20.4 years. It also very unlikely that the statistics obtained for a sample will be identical to the parameters for the entire population. Neither sample has statistics that are exactly the same population parameters. And it shows only 2 of the hundreds of possible samples. Each sample will contain different individuals and will produce different statistics. So this is the basic concept of sampling error. Sample statistics vary from one sample to another and typically are different from the corresponding population's parameter. So, sampling error. Sampling error is demonstrated if, for instance, you are in a statistics class and you have been separated in 2 groups by drawing a line from front to back through the middle of the room. Now, we have to imagine that we're going to compute the average age or height or IQ for each group. Will these 2 groups have exactly the same average? Thus, it's naturally occurring discrepancy or error that exists between a sample statistic and the corresponding parameter. So, almost certainly they will not. So, as an answer to the questions, no matter what we're going to choose to measure, we're going to probably find some differences between 2 groups. So the unpredictable and systematic differences that will going to exist from one sample to another, these are an example of sampling error. Then the next one, we have the population of college students. So this figure shows an overview of a general research situation and demonstrates the roles of descriptive and inferential statistics play. So here, the purpose of the research is to address questions that we posed earlier. So, do junior high school students learn better through modular or through online? So, there are 2 samples are selected from the population of high school students. And the students are in sample A are given printed pages to study for 30 minutes. And then in the sample B, studied on the same text on a computer screen. So, next, after that, the students will be giving multiple choice tests so that we can evaluate their knowledge of the material. And then the researchers has 2 sets of data, the scores for sample A and the scores for sample B. Now, this is the time to begin using the statistic. First, descriptive statistics are used to simplify the pages of this data. For example, a researcher could draw a graph showing the scores for each sample or compute the average score for each sample. So we have to take note the descriptive methods provide a simplified and organized description between the scores. So here we can see that the students who studied printed pages had an average scores of 26 on the test, and the students who studied text on the computed average is 22. So once we describe the results, our next step is to interpret the outcome. So this is the inferential role of statistics. We can found a 4 points differences between the samples. The only problem for inferential statistic is we have to differentiate between the following interpretation. So these are the interpretation. The number 1, there's no real difference between the printed page and a computer screen, and the 4-point difference between the samples is just a sample or a sampling error. Number 2, there really is a difference between the printed page and a computer screen, and the 4-point difference between the samples was caused by the different methods of study. So the 4-point difference between samples provide a convincing evidence of difference between the two studying methods? Or is the 4-point difference just a chance? The purpose of inferential statistic is to answer this question. So, we're done with our objectives for today. So, it's time for us to have a short quiz. Number 1. A researcher is interested in the sleeping habits of Filipino high school students. A group of 50 students interviewed, and the researcher finds that these students sleep an average of 6.7 hours per day. For this study, the average of 6.7 hours is an example of, is it parameter, statistic, population, or sample? The correct answer is statistic. Number 2. A researcher is curious about the average IQ of registered voters in the Metro Manila. The entire group of registered voters in Metro Manila is an example of sample, statistic, population, or parameter. It's population. Next, statistical techniques that summarize, organize, and simplify data are classified as descriptive statistics. And next one, in general statistical techniques are used to summarize the data from a research study, and statistical techniques are used to determine what conclusions are justified by results. Inferential descriptive, descriptive inferential, sample population, or population sample. It's descriptive inferential. IQ tests are standardized so that the average score is 100 for the entire group of people who takes the test each year. However, if you selected a group of 20 people who took the test and computed your average IQ score, you probably will not get 100. What statistical concepts explains the difference between your mean and the mean for the entire group? Statistical error, inferential error, descriptive error, or sampling error? It's sampling error. So that's it for today. I'll be seeing you again for the part 2 of our statistics lesson. Bye!